Here I have taken an example A 1, 3, 5 and B as an odd natural number less than 6. A subset in an interval form, and this is in the roster form. So you can write this from roster to interval, interval to roster here again. So minus infinity to infinity in an interval form means the set of real numbers. Power set means the collection of all subsets of a given set. Hello everyone, this is your Shruti ma'am, lecturer in Vidhyaashram, the Temple of Excellence, Mysuru. I am welcoming you to the third session of the chapter sets. So let us recall what are the concepts we have learnt in your second session. So types of sets, we come across different types of set. The first one is null set, a set which does not contain any element and is denoted by the symbol phi or empty braces. You are not supposed to write two things in the same like this. So this is not. So you denote it either with phi or with empty braces. And next, singleton set which contains only one element. Finite and infinite set. So a countable set, the set is which is countable is called finite. Empty set is also finite because you can count. That is, there is no number of elements inside it. And infinite, the set which is not countable. For example, set of natural number, set of even numbers, set of prime numbers, set of integers, real numbers, or an example for infinite set. Next, we come across equal set. So, two sets A and B are said to be equal if all the elements are in B and all the elements in B are in A. That is, they should contain same element inside it. Then only we say that they are equal set. So, we'll take few more topics in today's session. So, first one is the subset. So, what is subset? How we denote subset? Next, we will define the intervals as a subset of R is the set of real numbers and power set and universal set. Subset. What do you mean by subset? When we have a set A and set B, we say that A is a subset of B if every element of A or the element of B. That means all the elements in A should present in B. For example, I'll take set A is equal to A comma B and set B is equal to A, C, B, D. What is the condition here? A is said to be a subset of B if all the elements of A, what are the elements of A here? A and B must present in B. Yes, we have the elements A and B in set B. So therefore, we say A is a subset of B. So this is the symbol to denote the subset. One more example, general example I have taken here. The set of rational number is a subset of real number. We know that real number is a union of rational and irrational. So therefore, all rational numbers are nothing but real numbers. Therefore, rational number is a subset of real numbers. Next, I have taken set A as 1, 2, 3, 4. Set B as 1, 2, 3, 4, 5, 6. Clearly, all the elements of A are in B. So, we say A is a subset of B. If they are equal, all the elements must be same. But when you say subset, the condition is here, elements of one set must present in another set so that we can call that one is the subset of the other set. Next, we come across proper subset and superset. What do you mean by proper subset and superset? Proper subset means if A is a subset of B and A is not equal to B here. So, we come across certain sets where A and B are equal. Remember the definition of equal sets. A and B are said to be equal if all the elements of A are in B and all the elements of B are in A. That is, they contain same number of elements. But here, A is subset of B, but they are not equal to B. So I have taken an example here. A is 1, 2, 3 and B is 1, 2, 3, 4. We have all the elements 1, 2, 3 in B. But A is not equal to B here. So A is not equal to B, but A is clearly the subset of B. We call A as a proper subset and B as a superset. So whenever A is a subset of B and A is not equal to B, we call set A as a proper subset and set B as a superset. Here are some important points you should know about the subset. So here I have taken an example A 1, 3, 5 and B as an odd natural number less than 6. What are the odd natural numbers less than 6? So that is B. So 1 is less than 6, 3 is less than 6, 5 is less than 6. You can clearly say A is a subset of B, isn't it? All the elements of A are in B. So therefore we say A is a subset of B. Similarly, all the elements of B are in A. So we can write B is also subset of A. Whenever these two conditions holds, we can clearly write A is equal to B. So this statement can be considered as the definition of equal sets also. If A is a subset of B, B is a subset of A, that means A and B are equal. But when you come to the proper subset, A is not equal to B. It is strictly a subset of B. Second example, A is A, E, I, O, U and B is A, B, C, D. So here neither all the elements of A are in B nor all the elements of B in A. So what? So A is not a subset of B, also B is not a subset of A. You can find only element A in B, not other elements. Similarly, here also, except A, there is no B, C, D inside A. So therefore, A is also not a subset of B and B is also not a subset of A. Symbolically, we can write A is not a subset of B, also B is not a subset of A. Next, every set is a subset of itself. According to this definition, so if A is equal to B, A can be subset of B, B can be subset of A. Similarly, when A is equal to A, that means what? A is a subset of A. So therefore, remember this, every A set is a subset of itself. Next, empty set is also a subset of every set. That is, symbolically we write empty set is a subset of A because empty set does not contain any element. So therefore, it can be a subset of any set. Here are sets in mathematics. So N natural numbers, Z integers, Q rational and R is real. J is irrational, I have taken. So we know that set of natural number, that is 1, 2, 3, contains in Z because Z contains all the natural numbers. So therefore, we can write natural number as a set of integers. And all rational numbers are nothing but integers. Any integers can be written in the form of P by Q. So therefore, integers and natural numbers are also subset of rational numbers. And clearly, rational number is a subset of real numbers and irrational numbers is a subset of real number. But remember, rational is not a subset of irrational or irrational is not a subset of rational. Why? Any number which is rational cannot become irrational number and any number which is irrational cannot become rational. So they are different, but their union is always real number. All rational and irrational numbers are nothing but real numbers. Therefore, we can write Q as a subset of R and J as a subset of R. Real numbers contains all natural, whole numbers, integers, rational and irrational. So we can consider it as a universal set, which we will discuss it later. Consider the set empty. A is equal to 1, 3, B is equal to 1, 5, 9, C is equal to 1, 3, 5, 7, 9. So we are just inserting the symbol subset and not a subset between the sets. We know that every set is a subset of itself. Also, empty set is also the subset of any set. So here empty is given, set B is given. According to the statement, empty set is a subset of any set. We can write it as a subset. Now A and B is given. We have A as 1, 3, B as 1, 5, 9. But 1 is there in B, 3 is not there in B. So therefore, we can clearly write it is not a subset. To become a subset, all the elements of A must be the elements of B. But here, 3 is not an element of B. Therefore, it is not a subset. Coming to the third question, A and C. We have 1, 3. We have 1, 3 in C. So therefore, we can clearly write it as a subset. B and C. B is 1, 5, 9. C also contains 1, 5, 9. So all elements of B are present in C. So therefore, we can write B is a subset of C. Next question. Here is a question given. Let A, B, C are 3 sets. If A belongs to B and B is a subset of C, is it true A is a subset of C? If not, give an example. When we use the symbol belongs to is used for an element, whether it is in the set or it is not in the set. So let me take an example and verify whether A is a subset of C. If not, let me justify how it is not. I'll take an example. Let A is equal to 1 and A belongs to B means what? This element, this A must contain in B. So how we will write? I'll take B. Since A must be in B, I'll write 1, 2. One more element I am writing. So this is nothing but what? Your A. So according to this statement, A belongs to B. Why I am writing this? Since A belongs to B is given. So I have to write, don't write 1 because 1 is the element of A, but 1 is not the element of B. Here the condition is A belongs to B is given. So complete set A must be written inside the flower brackets. And one more condition, B is a subset of C. So take C as 1, 2, 3. So according to this 1, this is nothing but A and A are there, 2 is there. So we can clearly write B is a subset of C. Now what is the condition given? A is the subset of C. So A contains the element 1, but C does not contains the element 1. It contains the set. It contains the set A, but not the element 1. If it is an element, it should be written separately without flower braces. So we can clearly say A is not a subset of C. Why? Note that element cannot become a subset. So here this is element. So if element cannot become a subset of any other set. So no element can become a subset of any other set. So what we can write here as a reason, 1 does not belongs to C. So when you have an element as 1 in the set A, the same element should be in set C also. But here this is not an element, this is a set, that is A. So therefore 1 is not there in C. So therefore we can write A is not a subset of C. That is, so no element can become a subset. So here this is an element. If you write this as a subset of C, that is wrong. So therefore no element can become a subset. Only a set can become a subset of another set. So next question given here. Make correct statements by filling in the symbol subset and not subset in the blank spaces. So 2, 3, 4. So we can directly write it is a subset because 2, 3, 4 is in the second set. A, B, C, clearly we can write it is not a subset. Next, X is a student of class 11 in your school and X is a student of your school. So we know that a school or a college contains all the classes from Montessori to class 12 or Montessori to class 10. So when you come across your school here, so class 11 means first PUC students or the students of your college also. Yes, it is an example for a subset. Next, circle in the plane, circle in the same plane with radius 1 unit. A circle in the plane means there may be number of circles of different radius. And second set is a circle in the same plane which is containing only radius 1 unit. So this cannot become a subset. Why? Because this is the larger set. This set contains all the circles with different radius, but this set contains only the circle of radius 1 only. So this is the smallest set and this is the largest set. So therefore this set cannot become a subset of this. And triangle in a plane, rectangle in a plane. So no more connection with triangle or rectangle because this is a 3-side figure and that is a 4-side figure. So clearly they are not a subset. Next question, examine whether the following statement is true or false. Given A comma B is not a subset of BCA. Actually AB and BCA. So this is a subset of this. But they have given it is not a subset. So therefore the given statement is false. Next, AE is a subset of ovals in English alphabets. We know ovals in English alphabets means it contains A, E, I, O, U. So this set has the elements A, E, I, O, U. Clearly, AE is in this set. So therefore, the given statement is true. Next, 1, 2, 3 is a subset of 1, 3, 5. No, because 2 is not in this set. So the given statement is false. Next, A belongs to ABC. Again, this is false. Because if this element is in this set, then it should be written in this form. So this is true actually. So this is correct. So if this element must be in this set, then it should take this form, not only A. So therefore, the given statement is false. Next, let A is equal to 1, 2 and this is one set again inside the set, a set inside the set. Which of the following statements are incorrect and why? So given 3, 4 is a subset of A. So this is false. Why? Because 3, 4 is an element in A. If it is an element in A, we write it as belongs to. Belongs to. We will not use the symbol subset. An element cannot become a subset. It is just an element. So the symbol used here is wrong. Therefore, the given statement is false. 1 belongs to A. Yes, 1 is in A. So therefore, the given statement is true. So no reasons. Again, 1, 2, 5 is a subset of A. So you can write 1, 2, 5 as a subset of A if you take it as a subset. So therefore, this is true. Next, 1, 2, 3 is a subset of A. False. Because 3 is inside some bracket, that is inside one more set. 1, 2 are in A, but 3 is not in this form. So therefore, the given statement is false. So next, empty set belongs to A. False. Because a set belongs to A is not possible. How we can replace this? We can write empty set as a subset of A. This is not an element. This is a subset. Next, and as I said, the symbol itself is wrong. So therefore, the statement is false again. If this must be true, either it should be in this form or in this form. But this is false. Next, we come across a very important topic, that is intervals of a subset of R. Any real number can be made as a intervals which is a subset of real numbers. How we will write that as an intervals as a subset of R? We'll take a look. Let A comma B belongs to R and A is less than B. This is the condition. Then how we have different intervals in a real number? The first one is open interval. Any open interval is always written in the common bracket. So this is A comma B within the common brackets. So what does this mean? So it means it has all the points between A and B, but A and B themselves do not belong to this interval. So how we will write it as a definition? That is A comma B means it can take all the real numbers between A and B, but not A and B. Here I have taken an example, minus 3 comma 5. So what are the numbers, or what are the real numbers or any integers we can write from minus 3 to minus 5? So after minus 3, we'll get minus 2, minus 1, 0, 1, 2, 3, 4. 5 cannot be written because in an open interval, A and B themselves do not belong to the interval. So that means you have to exclude the given numbers and write only the numbers between A and B. Similarly, one more number I have taken, 2 comma 7. So 2 cannot be written, 3, 4, 5, 6 and 7 cannot be written. This is how we write an open interval of any real number. So if you want to represent it in a number line, I'll take an example of 2 comma 7. Let me represent it on a number line. So if you have a number line like this, so let me start with 2, 7, 3, 4, 5, 6, 7, 8, etc. So you can extend number line. How you will denote this in a number line? You are not going to include 2 and 7. So wherever you have 2 and 7, you are just writing an open circle. That means you are not including the number. So when you are not including the number, you are just writing an open circle above the number, and you can take all the numbers. This is the real number line. You can take all the numbers from 2 and 7. So therefore, you will draw like this. This means what? You can take any number between 2 and 7 except 2 and 7. And this is denoted by the interval 2 comma 7. So this is the real number line. Here I have taken only integer part. So this is how we will represent any open interval. So for an open interval, you are just writing an open circle for the above numbers and shading dark for all the and shading dark for rest of the numbers. Next we come across closed interval. So how closed interval are written? In big brackets A comma B. That means you are including the intervals which contains the end point. So in an open interval, what you will do, if any 2 comma 7 is given, you are writing only the numbers between 2 and 7. But in a closed interval, you are considering or you are including 2 and 7 also. So therefore, here you are using big brackets. So big brackets represent that you are including a number. Here I have taken an example, minus 2 comma 2. I am just writing only the integer numbers here. So minus 2, minus 1, 0, 1, 2. This is how you will write it in a set roster form. So 3 comma 8, 3, 4, 5, 6, 7, 8. So this is a subset in an interval form and this is in the roster form. So you can write this from roster to interval, interval to roster here again. And again, when you are writing this on a number line, how you are going to represent? Let me take this example, minus 2 comma 2. So I am writing a number line here. So we have 0, plus 1, plus 2, plus 3 and here minus 1, minus 2, minus 3. My interval is from minus 2 to plus 2 and this is closed interval. So closed interval means you are including the given number. So minus 2 you are writing a closed circle and here also plus 2 you are closed circle and you are just shading it with the dark line. That means what? You can take all the numbers from minus 2 to plus 2. This is also an example. So this is how the real number line represents. And along with this open interval and closed interval, we have two more intervals. They are called half open, half closed interval. For example, here one more condition, A comma B. This means what? You can see here big bracket represent you are including the number. So when you are writing in terms of intervals or when you are writing in terms of set builder form, so what you are going to write? You are writing X such that A less than or equal to. So here the inequality is lack. That means you are including A. When you have equals, that means you are including A. And here you have open, so you are writing strict inequality. You are not writing equals there. So therefore you are excluding B. And here one more interval, open interval A, closed interval B. Open interval A means A less than X. Closed interval B means less than or equal to B. So whenever you are writing less than or equal to, that means bracket you should use is big bracket. When you are writing less than, it is a common bracket, that is open interval. So what does this represent? So this is an interval from A to B, including A, excluding B. And this is an interval from A to B, including B, excluding A. When you have the term excluding, you are going to write open interval. When you have the term including, you are going to write closed interval. So note some important points when you come to the interval. So here we have a set A from -3 to 5. That is open interval -3 to 5. So clearly open interval -3 to 5 means it contains all the elements between -3 and 5. So and here B is a set from -7 to 9. So A means what? Set A is open interval -3 to 5. So you have all the elements from -3 to 5 and set B. Set B is from -7 to 9. All the elements from -7 to 9. Clearly we can say A is a subset of B because -3 and 5 come in between here. So here you have a set A inside set B. You have a set A inside set B. That means you have all the elements of A in B. So therefore A is a subset of B. Next, whenever you come across statements like non-negative real numbers, negative real numbers, real numbers, that can also be converted in the form of an interval. How? Non-negative real numbers means what? You are not taking negative real numbers. That means you can take all the numbers from 0, infinity. A real number line is from -infinity to +infinity with 0. So this side you have all negative real numbers. So negative reals, and here you have positive reals. So when you are not including negative real numbers, you are taking from 0 to +infinity. So therefore, you are going to write non-negative real numbers in the interval form as closed interval 0, open interval infinity, because infinity is not defined. Therefore, we have taken open interval there. And what is -infinity? So -infinity to 0 means you have all the negative real numbers to 0, but not positive real numbers. How the set is defined? Set of negative real numbers. So set of negative real numbers. So that is open interval -infinity to open interval 0. Next we have set of real numbers. I said set of real numbers means from -infinity to +infinity. We doesn't know the value of infinity, so we use a open interval. So -infinity to infinity in an interval form means the set of real numbers. So I have taken a interval and set builder form. So how we will write it in a set builder form? We can write it in a roster form also. So open interval -5 to closed interval 7. When you have open interval less than, closed interval less than or equal to. So how we will write? X such that X belongs to R, because we will consider intervals as a subset of real number. So any X you are going to write is the set R from -5 less than X less than or equal to 7. So why less than or equal to? That means you are including 7. When you are including something, write the symbol less than or equal to. Next, minus 3 to 5, we have closed interval for minus 3. That means you are including minus 3, therefore less than or equal to. Open interval 5, not including 5, therefore less than 5, strictly less than 5. So this is how we can convert an interval to set builder form and set builder to interval form. Next we come across length of an interval. What do you mean by length of an interval? If you have an element a comma b inside the interval, then b minus a will give you the length of a interval. That is, for example, minus 3 comma 5 I have given. So 5 minus of minus 3 is equal to 8. So this represents the length of given interval. So as I said earlier, you can represent any interval in the number line also. So let me show you how we can represent all these numbers in an interval. Suppose let me take an open interval. Open interval a comma b means you are excluding a and b. So how I can write? I can write this as, so this is your a and this is your b. So open circle for an open interval, and you can include all the elements from a to b. So we will make it dark. Next, let me take a closed interval. So this is nothing but your open interval a comma b. Let me take closed interval a comma b. So how you are going to represent it on a number line? So closed interval means you are including. When you are including, closed circle for a and closed circle for b also, and shade dark line in between a and b. So that means you can take all the values from a to b. Next we come across half open, half closed. So let me take half open, half closed. How we are going to write this? Open for a, so open circle for a and closed for b. So just shade in between numbers using a dark line. So you can take all the numbers after a to b. Next we have the last interval, closed a, open b. So how we are going to represent closed a? That means you are including a. So a excluding b. So shade with a dark line in between a and b. So this is how we are going to represent a given interval in a number line. Next, write the following as an interval. So we are supposed to write, this is in the set builder form. We are writing it in a interval form. Now we have minus 4 comma 6. But what about an interval, open interval or closed interval? You have less than here. So when you have less than open interval, here you have less than or equal to, that means you are including, so closed interval. So this is how we will denote it as an interval. Next we come across minus 12 less than x less than 12. We have a number minus 12 and minus 10. What about it is open or closed? Minus 12 strictly less than open. Minus 10 is also strictly less than open. That means you are excluding. So this is an example for open interval. Next, we will write interval to set builder form. So when you are writing set builder form, x such that, this is the condition. Now how I can write? Minus 3 and 0 I can write. What is the condition? Both are open interval. So less than x, less than 0. So this is how we are going to write. And here what is the condition? X belongs to, here are the intervals given. We are going to convert it into set builder form. So when you are writing it in a set builder form, open bracket x such that. So intervals are for real numbers. So therefore x belongs to R. What about the condition here? We have minus 3 and 0. And in between I should write x. What is this symbol? So both are open. So strictly less than. Next we have again minus 23. So x such that x belongs to R. And minus 23 you have a closed interval. So therefore minus 23 less than or equal to and x less than 5. So this is how we will write a given interval. Next we come across a very important concept called power set. What do you mean by power set? I said for any set you will have a subset, and writing all the subset as another set is called power set. So power set means the collection of all subsets of a given set. For example, consider the set 1, 2. Let me take a set as 1, 2. What are the subset? We know that empty set is also subset. If I write 1 separately, that is also subset. If I write 2 separately, that is also separate. And if I write 1, 2 as one more set, I said every set is a subset of itself. Therefore, 1, 2 is a subset of 1, 2. So if you write this as a collection again, as a collection of one more set, that is power set. So that is writing all the subset inside one more set is nothing but power set. Now, how many elements can power set have? For example, in the previous example, so we have 2 elements here. And how many elements does power set have? We have 4 elements. So how this can be calculated? Using a simple formula, that is 2 power m. That is, if n represent cardinality of A. Cardinality is nothing but number of elements in the given set. Suppose A is a set and n of A denotes m is the number of elements in the set. Then number of elements in the power set is 2 power m. For example, if a set Z contains 4 elements, then power set contains 16 elements, that is 2 power 4. I'll take an example. Write down all the subset of the following sets. So here one set is given, set A. So if I denote it as set A, then power set of A given by, first you write empty set and also set A. So I cannot write any other elements. So therefore the only elements are 2 elements, that is empty and A. How many elements we have? 1. How many elements? Here we have 2 power 1, which is equal to 2. So if you have m elements here, then here you should contain 2 power m elements. Then we have A, B. Suppose I write A is equal to A comma B. What are the elements in the power set I can write? Empty set and singleton sets, A and B. And along with that, every set is a subset of itself. Therefore, I can write A, B also. So therefore, this is the power set of the given set. How many elements we have? 2. How many elements here we have? 2 square is equal to 4. 1, 2, 3. Suppose I write this as 1, 2, 3. Then what are the elements in power set? One is empty set and singleton sets. 1, 2, 3 and sets which contains 1, 2, 2, 3 and 1, 3. And the complete set 1, 2, 3. How many elements we have here? We have 3 elements. Then it should contain 2 cube elements. 2 cube elements. Check it. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this is how we can calculate the number of elements in the power set. So number of elements in the power sets depends on the cardinality of the given set. Now empty. So empty, only empty in the power set also. So empty set means there is no elements inside the set. No elements means number of elements is 0. So therefore 2 power 0 is equal to 1. So therefore for an empty set, power set contains only 1 element. So here is one more question. Same. If A is empty, what is its power set? I explained it. What is its power set? I said previously, now empty set means it does not have any elements. So if it does not have any elements, then the number of elements in the power set is only empty set. So therefore, if A is equal to empty, means number of elements in the power set is 0. So therefore, how many elements in the power set means So number of elements of power set of A is 2 power 0, which is equal to 1. What is that element? Empty set only. Empty set only. Remember, when it comes to the power set, the subsets inside the power set will become the elements of power sets. Next is universal set. What do you mean by universal set? Universal set means it contains all the elements for the given problem. As I said earlier, so real numbers can be considered as a universal set for natural numbers, rational numbers, irrational numbers, because real numbers contain all those numbers inside it. So when you say it as a universal set, it becomes a parental set for the subset, or many other subsets can be derived from the universal set, and it is always denoted by capital U. Here are few examples I have taken. Let me suggest universal set for the examples given here. First one, so question, what universal set would you propose for each of the following? The first question is given, the set of right triangles, that is right angle triangle. So if I take set of right triangle as the smallest set, then universal set can be written as set of all triangles. This form a parental set for the given set, because all right angles can be derived from this given set. Next, set of isosceles triangle, you can write the same, because set of all triangle contains all types of triangles, whether it is equilateral, isosceles, equiangular, right angle triangle, etc. Set of integers, so Z, okay, I said real number can become a universal set for any other sets. So therefore, I can write U is equal to R, or simply I can write the set of real numbers can form a universal set for this. Next, set of rectangles. I can write universal set of quadrilaterals. Or I can write it as set of plane figures. So that means because rectangles contains in quadrilaterals, quadrilaterals may have square, rhombus, trapezium, parallelogram. So it contains all four-sided figures, and rectangle is one among them. So therefore, for this set, I can take set of quadrilateral as a universal set. So in this session, we have learnt about the subsets and formation of subsets and writing all the subsets in one more set, that is power set and universal set. Also, we have learnt how to write any intervals of a subset in the real numbers when it comes to open interval and closed interval. So very important concept. So learn them in detail. So we'll meet you in the next session taking few more concepts on the chapter. Until then, keep watching, keep learning and keep exploring. Thank you.